What makes us excited and me excited is one is the application of these in the real world, and the other is the combination of these, right? So in IBM research, we look at all these four areas: generative AI, quantum computing, hybrid cloud, and semiconductors. So when you look at them separately, they're all different. But when you look at them together, you realize that you can actually bring all of these together to go beyond any one of these good on their own. If you are building generative AI models and solutions, but if you can optimize the hardware, if you can optimize the hybrid cloud deployment architecture, you can actually do a much better job of achieving the same qualities with much more effective, cost effective, and performance effective stack. So we are able to bring our research at the hardware level, developing AI chips, and also our research at the platform as a service or hybrid cloud level, working with Kubernetes ecosystem and advancing the Kubernetes ecosystem for generative AI workloads, while also optimizing the AI applications that would work on this. So then when we look at quantum, we also then can see how quantum computing can help with machine learning, because quantum computing opens up the possibility of new kinds of kernel spaces that were not accessible by classical computing, which can open up new ways of learning from less data, learning more patterns from less data, because now you have access to more spaces to map your data to. And when we look at all of this from a hybrid cloud lens, we can also think about how these hybrid computing systems can be deployed, where you have quantum computers with GPU-based infrastructure, with CPU-based infrastructure, and HPC. How do you use all of that with hybrid algorithms to solve really hard problems? So this combination of things is particularly exciting. And then when we look at applications in the real world, where we can impact it.